Hi, chemistry peeps. This is your instructional helpfulness for specific heat calculations. So this is posted on Canvas, and the previous calculations were for heat of vaporization, specific heat, and heat of fusion. Now this one is just specific heat, and the reason I did this separately is because we know the specific heat of water. But if you look on your reference tables, you will see the specific heat for water is 4.18. But look at all these metals you've been given the specific heat for. Okay, so I just wanted to use some of these and switch it up a little bit. So for the first one, okay, you have to underline what you know in the question. All right. So 22 grams is always mass, right? So M equals 22. 713 joules. So when you see something measured in joules, in this case, we know it is Q, and that's the heat. So 713 joules. When it is heated from 28.3 to 72.8 degrees Celsius, so what is the specific heat of the metal? So your delta T is your change in temperature. So 72.8 subtract 28.3. And what do you get? Get my handy dandy calculator. Well, 72.8 minus 28.3. And that gives you 44.5. And that is degrees Celsius, okay? And so it's asking for specific heat, which is your C sub P, okay? So let's plug it into, here's your equation for all of these. Q equals M times mass times specific heat times change in temperature, okay? So let's work on plugging this in. So we already know our Q, so that is 713. Equals mass times the specific heat, which we don't know, times the change in temperature, which we found was 44.5. Okay, and so now what you do is you have to multiply that 22 and 44.5 together. So 22 times 44.5 equals 979. So what you're going to do is you're going to say 713 equals CP times 979. Now how do we get CP, specific heat, by itself? We got to get rid of this 979. So divide both sides, because what you do to one side you have to do to the other. That crosses out, so CP equals 713 divided by 979. And that gives you an answer of 0.73. And then square your answer, okay? So that's how you work these specific heat problems. They're super easy. I know that the equations seem a little scary when you look at them, but I promise you it is just multiplying and dividing, okay? So let's pick another one I've set up. This one gives you the specific heat. So you have to solve, you have to rearrange the formula, or you have to plug it in. It's up to you. If you want to plug it in, then solve for it. And I can help you if you need help on that. These, number 3 and 4 and 5, work exactly, and number 6 work exactly like solving for Q, which is what our formula does. But what you have to do, starting with number 3, look over here. It says copper, but it doesn't give you the specific heat. So CP of copper, come over to your reference tables and you find copper. This is the specific heat, 0.385. So that's what I came over here and wrote in. And I wrote, of course, reference tables to remind you. And so we can say Q equals mass times the specific heat times delta T. And it was, it gave us 35 and 25, which is a difference of 10. I should say degrees Celsius. So multiply that, okay? And when you multiply all of that together, you're going to get Q equals 1925 joules. And then put a square around it, okay? And so the same thing you're looking for here, you have to find iron. So I'm gonna write CP equals, I'm gonna come over here and I see iron right here is 0.449. So I'm gonna fill that in, 0.449. So that's what you know to plug in. This one also is how much heat, so you're solving for Q. This one is also solving for Q. And the last one is also solving for Q, so you don't have to rearrange those. So I hope this helps. Please finish this and submit, and I will grade it and see how you do and give you some feedback. Thanks.